We use chemical formulas to represent compounds. In the chemical formula, we indicate what elements are present in the compound and how many atoms of each element are present. So we use the element symbols, like here's the example for water. We've got H for hydrogen and O for oxygen. And then subscripts indicate the number of atoms of each element. So H with a subscript 2, subscripts go below the middle line, like submarines go below, and superscripts go above, like Superman flies over the city. So this is a subscript. H2, that tells us there's 2 hydrogens. And there's 1 oxygen. So we have this implied subscript of 1. Here's another case where chemists don't seem to like writing the number 1. We figure, well, I wrote the O. That tells you there's oxygen. If there was more than 1, I'd put a number there. And if there was no oxygen, I wouldn't have put the symbol. So I'm going to save myself the trouble of writing the 1. So H2O means 2 hydrogens, 1 oxygen. Here are some common formulas. NaCl. So that's table salt, sodium chloride. There is 1 sodium atom for every 1 chlorine atom. So that's a 1-to-1 ratio by numbers of atoms. That's not the same as the mass ratio. CO2, we just looked at an example of that one. No, we did carbon monoxide, my bad. CO2, carbon dioxide, 1 carbon, 2 oxygens. Okay, this is one of the predominant gases in the air. You exhale it and the plants use it and give off oxygen for us. Sucrose, table sugar, C12H22O11. 12 carbon atoms, 22 hydrogen atoms, 11 oxygen atoms in a molecule of sucrose. So that's what the chemical formula means. The subscripts are very important. You change a subscript, you change the compound. So we can make different compounds out of carbon and oxygen. There's CO and there's CO2. Details matter. CO is carbon monoxide. This is a pollutant in the air, and every year in the United States, many people are killed because of carbon monoxide poisoning in their own home. It's very, very tragic. CO2 is carbon dioxide, relatively harmless. We exhale it all the time. It's always present in the air around us. The difference in the formula is 1 number. So I know that students often get frustrated because, well, but I meant, yeah, but there are some times in life where a detail matters. If you have an important email to send to your boss and you get 1 letter wrong in the email address, is he going to get the email? No. And if you're really unlucky, someone else might have that email address and it won't even bounce back to you. It'll just go through and you'll think everything's fine, and your boss is like going to fire you because you didn't send him this important document. There are times when details matter. Details matter for chemical formulas. I am not going to try to trick you or get on you about which element comes first in a chemical formula, but I know that some of you might wonder, well, why do you always list the sodium before the chlorine? We do have rules about these things and conventions. We list the more metallic elements first. So if you have a metal and a nonmetal, the metal is always going to come first. And this works in well with my thinking that the metals are masculine and the nonmetals are feminine. How do you address a formal wedding invitation? Is it Mr. and Mrs. or Mrs. and Mr.? Mr. and Mrs. Why? Because we've always done it that way. It's what everybody does. It's convention, right? We always put the metal first, just like you always put Mr. first when you're addressing Mr. and Mrs. But what if you don't have a metal and nonmetal? You put the nonmetal that's closer to the metals first. So here we have a metal and a nonmetal. It's always going to be NaCl, not Cl, Na. That looks silly to a chemist. We would write N2O instead of O, N2. I understand that these represent, in theory, exactly the same thing. 2 nitrogen atoms and 1 oxygen atom. But when we look on the periodic table, we see that nitrogen is to the left of oxygen. It's closer to the metals, right? So the one that's closer to the metals goes first, and the one that's further away goes last. Here is a specific list that is generally followed. There are some historical exceptions, like in the hydroxide ion, the oxygen is written first, but generally speaking, that's the order. And again, I'm putting it out there, but I'm not gonna get you on that. So let's practice writing some chemical formulas. Compound containing 2 silver atoms to every sulfur atom. What's the symbol for silver? Ag. And it says 2 silver atoms, so what do? A subscript 2 after the silver. And then sulfur is capital S, and there's only 1, so we don't write a 1. It goes metal, non-metal. Silver's the metal, sulfur's the non-metal. Compound containing 2 nitrogen atoms for every oxygen atom. N2O. We look at the periodic table, we see that nitrogen is closer to the metals, so that's why he goes first. 1 oxygen, again, we don't write the subscript 1. 2 iron atoms for every 3 oxygen atoms. Fe2O3. Now, you need to do your best to make your lowercase letters small and your uppercase letters large. You know, if you get sloppy, well, is this CO, is that cobalt, or is that carbon monoxide? The size of the O matters. Okay, so be careful with that. Oh, we'll have to stop.